Okay, we're having a little trouble seeing this, okay?
For that one, could
Maybe
you
I should have started with whole number exponents over here, but let's just do this with whole number exponents. Go ahead.
Oh, for like the x to the 9/4, could you do like x to the 5/4 and x to the 4/4 or that?
You could, but let's look at what we do here. You're close.
Okay.
You're very close, okay? But let's look at what we've got here, okay? Why did I break it down like this? I mean, I could have broken down a to the 5th into a to the 4th times a, right?
Right.
There are a lot of ways I could break down a to the 5th. I could rewrite it. I could write it as a times a squared times a squared, right?
Mm-hmm.
Okay? But I wrote it as a squared a cubed. What about the denominator told me I wanted to write it as a squared a cubed?
Because it's b squared?
Yeah, denominator is b squared, the numerator. If I've got an a squared in the numerator, then I've got the same exponent for this and this, right?
Right.
Okay? So that can be written as a squared over b squared times a cubed, right?
Mm-hmm.
Make sense?
Yeah.
Which then can be written as a over b squared times a cubed. So if I've got powers of two different expressions, I can factor, because all I did was I factored this, right?
Right.
I factored a to the 5th into a squared a cubed, so I'd match the exponent in the denominator. Okay? Now actually with this one, this is good, okay, but even better, is that right? Okay, now how would it ever occur to me to do that? Well, it's just, if I look at this, you know, I've got something squared times a cubed, right?
Right.
Well, there's still a square sitting inside of a cubed, isn't there? So, okay, so I could have written this as a over b squared times a squared times a, right?
Right.
But a over b squared times a squared is a over b times a squared, so I can actually get this thing into this expression here, okay? Now better, I go down here and just say, well, b is squared, let's just pull out the biggest square I can out of a to the 5th, okay? So I pulled out the biggest possible square from the numerator, which is a square of a squared. And that ends up being what? A squared over b, quantity squared. Okay? So that's where it gets kind of tricky.
Yeah.
Okay?
All right.
But this anticipates something you do with radicals. And let's come back to this one for a minute, and then we'll go on and talk a little bit about how this works with radicals, okay?
Okay.
And in a few minutes, I'll run over and get the copies that I made. I should have had them, but this computer, Chrome isn't working, and I couldn't get the thing to download on Internet Explorer. So the computer's screwed up. But I've got another one back there, so I was able to go back and get it to work. But I didn't have it at the beginning of class because it had an unanticipated glitch, although you can pretty much anticipate you're going to have glitches.
Yeah.
It's the wrong time. It worked out. We got started in time. And I'll give you something to do while I go over and pick those up, which will only take a minute. Okay. Is this thing still on? Need to shut that guy up.